Okay, 3.2, families of graphs. I talk about the different types of transformations that you can do on different functions. If you have a function y equals f of x, and you put a negative on it, that causes a reflection across the x-axis. If you put a negative on the x, which is actually inside of the function, that will cause a reflection across the y-axis. This will make a lot more sense once we get into an example where we can look at the graphing calculator. If at any time you are struggling to copy these down while viewing the recording, please pause the recording as I'm going to go through these fairly quickly. Translations, again, we're using y equals f of x. If you add a positive value c is some positive number, then it will shift the graph up c units. If you subtract from the original function, then it will shift down. What if you add a positive number inside of the function? Okay, there's a little trick. When you're inside of the function, you do the exact opposite. So instead of it going to the right, as you think it would, it actually will go left, as stated. And if you subtract on the inside directly from x, it affects the horizontal, and it will be the opposite again. It will shift c units to the right instead of to the left. So inside, directly with x, inside of a function, possibly a square root, maybe a set of parentheses, an absolute value, any of those do the exact opposite of what you see. We also have what's called dilations. This is multiplication. So if we multiply a function by some number, it will expand by that number. Again, the first example here, c is greater than 1. So say like 3. If it was 3 times some function, it will expand vertically by 3. 3 times larger. And if c is between 0 and 1, that's a fraction, like a half or a third, then it will actually get smaller. It will compress vertically by a factor of c. Again, when we go inside the function, we are now multiplying x by c. That causes the opposite to happen. So if we are multiplying by a number larger than 1, say like 3, then it will actually compress, not get larger, by horizontally by the reciprocal of that number. So the factor is actually the reciprocal of the value of c. So if you figure out what the reciprocal is first, which we have over here, 1 over c, that will tell you if it's going to get bigger or smaller. Instead of looking at the original, automatically figure out the reciprocal if it is on the inside. For the last one here, c is between 0 and 1, for instance, like a half or a third. So if it's a 1/3, and we took the reciprocal of 1/3, that will give us a 3. So it will expand horizontally by a factor of 1 over c by its reciprocal. All right, let's get into some examples, see if we can make this make sense. We want to describe in words how the change from the original to the second function, g of x, describe how that happens, or what is happening when you put different things onto the function. In the first example, we have a negative of the absolute value of x. So this is new. So what does that cause? Now if we go back and look, putting a negative on a function causes a reflection across the x-axis. So that's exactly what's happening there. This is a reflection across the x-axis. That's the only thing that's new, so it's the only thing we have to talk about. Okay, here's another problem. We have the square root of x, and now we have the square root of x plus 2. The plus 2 is outside of the original function. So this is going to cause a shift up 2. It's up, it's vertical because it's outside of the original. It's affecting them up and down, vertical. It's a plus 2, so it's going to go up, up 2. Okay, here we have a -4 or x minus 4. This minus 4 is inside of the function. It is under the square root. It is inside, affecting x. So you do the exact opposite of what you think it's going to do. Okay? If we would subtract 4 from x, you think it would get smaller or move to the left if we were graphing it. Instead, this graph will shift to the right 4. All right, what's happening in this graph? Well, we have this plus 3 and we have this minus 1. The minus 1 is outside, so that's going to be a shift down 1. This is on the inside, so that's going to be the opposite of what we think. It's directly affecting x, so it's going to be a left or right. We think it's going to go right, but we do the opposite. So it's going to shift left 3. Okay, here we have the multiplication on the outside. Multiplication on the outside, if any time it's outside it affects the vertical, what you see is what you get. So we're going to expand vertically by 2, by a factor of 2. So it's going to get twice as big. Okay, here we have 3 things going on. We have a negative, we have a 0.5, and we have a -4. Okay, so the blue, that is going to cause a reflection across the x-axis. The red, okay, it's outside. It's going to affect the vertical. It's smaller than 1, so it's a compression. Compress vertically by 1/2, or 0.5. And the -4 is also on the outside, so that's going to be vertical. So that's a shift, since it's a subtraction, down 4. And when you look at this, you have to consider these in the order of operations. So all multiplications and divisions must be considered first. So we will reflect, since that's a multiplication. Then we'll compress, since that's a multiplication. And the last thing we'll do to the graph is shift it down. So multiplications have to be done before additions and subtractions. Now in this last case, we only have additions and subtractions. We have a -2 and we have a -3. The -2 is on the inside, so it's going to do exactly the opposite of what we think. We think it's going to go left 2. It's actually going to shift right 2. Now the -3 is on the outside, so that is going to affect the vertical. That's going to shift down 3. Okay, now I'd like to confirm all of these with a graphing calculus. We're going to go back to the first example. Okay, let's take a look at the graphs of these. Okay, the first function is the absolute value. We go to math, go to the right one to num. The first choice is ABS, absolute value of x. Okay, zoom 6. That's what the absolute value looks like. Now the negative on it should cause it to reflect across the x. So what's on top should reflect to the bottom. What's on the bottom should reflect to the top. Well, there's no bottom, so all we're going to see is the top reflecting to the bottom. We'll put a negative in front of that in the graph. As you can see, the top has been reflected to the bottom. Okay, second example. Our original is the square root of x. A square root of x, positive square root of x, is the top half of a sideways parabola. That's the best way to describe that. It starts at the origin and curves up and continues to increase. If we add 2, it says that should shift it up 2. So if we add 2 to it, instead of it starting at the origin, it should start at 2 and then continue to increase as we move to the right. So let's go ahead and add 2. And there you go. As you can see, it's been shifted up 2. It's no longer starting at the origin. If we hit trace, it's starting at 0, 2. It's been moved up 2 vertically. Okay, same start. Okay, back to the square root function, starting at the origin. Now we're going to put a negative 4 in the inside. Minus 4. This should shift it to the right 4. So what we saw at the origin should now be moved to the left, to the right 4. So it should start at 4, 0. And there it is. We hit trace, move over to 4. Actually, let's go ahead and calculate the value of 4. There it is. 4, 0 is where it started. So it's been shifted to the right 4. Okay. Again, square root functions where we're beginning here. At the origin, this one's going to be shifted left 3 and down 1. So the starting point is at the origin should move to the left 3 and down 1. So the starting point should now be negative 3, 1 when we're finished. Let's see if we end up there. Plus 3 minus 1. All right. Again, I can calculate the value at negative 3 to prove that it's starting at negative 3, negative 1. Okay, the next one we have for part E, the greatest integer. How do we type that in? Math, num, number 5, int of x. Now, this is a step function. Because this calculator connects up dots, and we don't want it to connect it up, we're going to change how this is graphing. Okay, a solid line would cause it to connect things we don't want it to connect. So we're going to move to the left of y1. You can see I put the cursor to the left of y1, and I'm going to hit enter. Once, we'll make it a thicker line. Twice, we'll make it shade above. 3 times, we'll shade below. This will graph with like a identifying ball on the front of it, so you know exactly where the graph is. This will graph just the ball. It will not show the actual graph. And then the dotted line, and that's what we want. We want a dotted line because we only want to see the dots, not the connected. So we're going to hit zoom 6 now that we've chosen that. And you can see our step function. We want to take 2 times that. Again, let's take a look at the graph. At x equals between 1 and 2, you can see that we're at y equals 1. If we're going to multiply by 2, that means it should expand vertically by 2. So that line that is currently at 1, okay, will now move up to 2. And 2 will become 4, and 3 will become 6, and so forth. So let me go ahead and insert that 2. And as you can see, the line between 1 and 2, instead of being at 1, is now at 2. And what was at 2 is now at 4, and so forth. So it has expanded it vertically by a factor of 2. All right, what's going on here? We have a reflection, and then a compression, and then a shift. So let's take this step by step. let's first go back to the original, and let's have it reflect. We're going to put the negative on it. So I'm just going to insert the negative to look at what that does. It has reflected it. What was on the top is now at the bottom. What was on the bottom is now on the top. It's reflected across the x-axis. And now we're going to compress it by 0.5. So if I put the 0.5 in, it should compress vertically. It should look like it's been smashed. So insert 0.5. And as you can see, it definitely has been smashed vertically. Now the -4 is going to cause it to shift down forward. So as you can see, it looks like it's passing through close to the origin. Now when we put the -4 in, it should shift down and be passing through about -4. And there you go. That's the final graph, and that's what we said it would do. Last example, we have x squared. Everybody should be familiar with this graph. It's a parabola at the origin. So what's going to happen to that parabola? Well, its vertex point is currently at the origin. If we shift it to the right 2 and down 3, our vertex point should now be at 2, -3. So the graph should shift down diagonally to the right. Let's go ahead and put that in there. X minus 2 squared minus 3. Just minus 3. Okay, here we go. And as you can see, it's been shifted down. If I calculate the value at 2, it should be 2, -3, which it is. So all we're doing is talking about where does the original graph start, where should it be finishing. We should be able to visualize and describe in words exactly what's happening to the original function. That's all we have for this lesson.